Hello guys, and here are the second part of our Chapter 2 notes where things get a little more challenging. And simply put, now we're going to be looking at systems with 3 variables. Oh my gosh, this is where it gets real. Okay, it's not too hard. You have different options, so I am going to show a few of them, but I'll try and do so quickly. The main thing is you need to take your time. So key number 1, take your time. And as usual, let's get started here. I like to label everything triangle, square, circle now, and we'll use those throughout. It's really important to organize your steps. If you're not a very organized mathematician at this point, please consider doing so. It will greatly help you. So the first step is we can use substitution. Okay, and there are different ways. So I like to start with substitution. Okay. So let's just take, square, and I'm going to solve for x. You could really choose any variable you want. You could solve for z, but I'm going to solve for x. So that means that x is equal to, so maybe square x, is equal to, well, if I add 3y to the other side, and add 3y to the other side, subtract z, bada boom, I have 10 plus 3y minus z. Okay, you can rearrange those in any order. So we have x solved for. Well, it's called substitution because now in the other 2 equations, so in triangle and circle, I can take and substitute the x on it. Okay, so this is going to be triangle now with our new and improved x. So I'm just going to be substituting that big ugly chunk into both of those. Key thing to do is make sure you put it in parentheses. You're substituting the entire quantity, 10 plus 3y minus z. That is what x is. Okay, the whole piece. And then don't forget the other guys. We have 3y, 2z, and 4. So plus 3y plus 2z equals 4. Okay, and again, we're going to do the same thing in circle. So we can call this maybe triangle x, circle with x. And with circle x, I have 5 times the quantity. Again, 10 plus 3y minus z minus 2y minus 3z equals 8. Okay, now we are going to simplify and continue. So triangle simplified and circle simplified. Well, if we distribute the 3, boom, 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 we have 30 plus 9y minus 3z plus 3y plus 2z equals 4. And in the bottom, so circle, is going to be 50 plus 15y minus 5z minus 2y minus 3z equals 8. Okay, now notice the big idea is we narrowed it down from 3 variables, now just down to 2. So I see y's and I see z's. That's it, no x involved. Okay, combine like terms, so even more. So we're going to keep simplifying. So triangle and circle. 9y plus 3y is going to be 12y. My z's are going to give me a negative z. And I'm just going to show if I subtract 30 and subtract 30, I'll have negative 26. Okay, circle, all new and improved, will be 13y minus 8z equals, and if I subtract 50, I'll have negative 42. Okay, from this point, it should look, hey, kind of familiar because it's just a system of 2 variables. which means you can, again, use substitution, you can use elimination. Either one is fine. Just to mix it up, we'll use elimination. So if I multiply the top, so I'm going to eliminate, let's go with z. Okay. If I multiply the top by a -8, triangle with -8 is then -96 plus 8z is equal to 208. You might be saying these are big numbers, but it's really going to be okay. Down below, I still have 13y minus 8z equals -42. Hey, hopefully solving these is getting to be a little quicker for you. 208 minus 42 gives me 166 is equal to, 8s are going to cancel out, and -96 plus 13 is -83. Y. And then we divide by -83, you divide by -83, and you get 166 divided by -83, and you get y is equal to -2. Alright, that's not too shabby. Now, here's the thing. So once you have 1, we still need to find x, and we need to find z. If you have one variable, here's the key thing, one variable, we kind of work our way back up, okay? If you know one variable, then we can substitute into an equation with two variables, okay? So, like one of the equations we made before, 12y minus z equals to -26. If we substitute it back into that one, we'll find z. Sorry, jump around here. So 12y minus z equals -26, which is really 12 times -2 minus z equals -26. -24 minus z equals -26. -2 equals -z. Z equals +2. Once you have two variables, you can then substitute into any one of the very originals with three variables. So let's stick with triangle from the very beginning. 3x plus 3y we know is -2 plus 2z we know is +2 equals 4. 4, -6, 3x, -6 equals 3x, and lo and behold, actually +6, sorry, +6 equals 3x, and x will equal 2. So to be clear, I added 6 over after subtracting 4, bada boom, bada bing. X equals 2, y equals -2, z equals +2. Give yourself a pat on the back, because yes, they are challenging, they take some time, but they're good for you, okay? So 2, -2, +2 is your answer. Yes, it took us some time to solve that, but you should feel rather accomplished after yourself. So maybe stretch out, give your hand a break for a minute after all that writing. One more quick example here. Special cases, inconsistent. Just remember, so this isn't the example, just remember, if your solution gets down to, say, 0 equals 6, or 5 equals 2, or something that's not true, okay, that means there are no solutions, okay? There can also be infinite solutions, just like this one here. So it's an infinite solution, but I'm going to show you why. Okay, so a dependent system of linear equations. Another way you can start out is through eliminating. So this time we're going to start out by elimination method, okay? And I like to, again, label everything triangle, circle, square, and that'll get you started. And again, kind of give yourself a roadmap. Say, I'm going to start with circle and square, and I'm going to eliminate, let's pick, make it easy, y. Okay, we're going to eliminate y. So to do that, if I take circle and square, and you always want to start with two equations, okay? Start it out with just two. So 10x minus 4y minus 6z equals 16, and 5x minus 2y minus 3z equals 8. Let's choose to eliminate y again, so we'll multiply the bottom by a positive 2, actually a negative 2. Okay, that'll make it negative 10x plus 4y plus 6z equals negative 16. And what do you notice here? If we are to add these together now, okay, 10x and negative 10x are going to be 0x. Okay, y and y are going to be 0y, and z, adios, is going to be 0z. And lastly, 16, negative 16 is going to be 0. Okay, now what we have here is essentially 0 plus 0 plus 0, 0 equals 0. That means there are infinite solutions. Okay, so again, you can either start out with elimination, you can start out with substitution. You would have wound up in the same spot. Okay, if you notice something like, hey, this is everything multiplied by 2, if you notice that off the bat, it's a good idea to check. Keep in mind, if we got maybe 0 equals 10, there would be no solutions, okay? So they are for systems of 3 as well, very dependent on your skills for solving systems of 2. Okay, so I do have a lot of practice with systems of 3, but that's the name of the game. Take your time, and what I would like you to post is, so an answer kind of to our essential question, is how do you begin to solve systems of 3 equations? Okay, that is the name of the game. Good stuff, and good luck practicing.